Let us now discuss how can we solve this problem. Number of ways to divide a long corridor. So to explain this problem clearly, let me take an example. This example. So we are given with a corridor, the string where S represent seed and P represent a plant, right? So let us take the same example, double S, double P, SPS, right? Double S, double P, SPS. So that means there are two seeds, seed, right? And two plants and a seed and a plant and a seed. Now we need to divide, we need to return the number of ways to divide corridors. This is actually a library. We need to return the number of ways to divide corridors so that every every corridor has exactly, they said exactly two seats, right? Now let us see what are the possibilities if I divide like this. Okay, it's good, right? Now there is another way that I can divide it in this way, right? Now there are two seats here. Seats are squares and two seats here, right? So yeah, that's good to divide in that way. Now the third way which I want to divide this is in this way. Now if you see, this is one corridor and this is one corridor. In every corridor, I have two seats. Now, this is one corridor, this is one corridor. I have two seats in every corridor. This is one and this is one. I have two corridors, right? Now, let's take an example. You might be thinking that we need to have only one division so that we get two corridors. Let me tell you, test result. Yeah, here this case, right? S double P 4 S PPS, S double P, S double P 4 S PPS. This is the string which we are given. So a seed and a plant, seed, seed. Seed is nothing but you can imagine it as a chair, right? Now if you see, I need two chairs or seat in every corridor. So, okay, I'm dividing or making a corridor here. Now, I need two seats. Now, I make here. Now, is there any other way other than this, right? Only one way we can have the corridors. But let me tell you, what if I was having a seed and two plants and a seed? Now, there are three plants here and a seed and a seed and a plant here and then a seed and then two plants and a seed. Now, how many different ways I can place, I can have corridors? Now, if you see, we need two seeds. One, two. Okay, I will place it here. Now, can I place it here? No, let us see. Let us see. But let us go and have how many corridors we can get. So these are plants, we don't need them. We need two chairs or seats. Now I placed it here. Now I have two seats in the next corridor. Now imagine, just imagine, if I was having another seat, then I will be placing a corridor here. I will be making this as a corridor and I will be having two seats. But if you see, this one seat, it's an error. So if I am having odd seats, then there is no way, and we'll be returning 0. Why? Because in one corridor we'll be leaving only, we'll be left out with only one seat. Okay, that's good to know. Now, is this the only way that we can place the corridors? No, not at all. I can place it like this, right? So there are two seeds even now. Now I can place it like this. Now let us see. Then again I am taking it again, and I can also place it here, or okay, I'm placing it over here, and then I can place it like this, right? Now, even now I have two seeds. Now I have placed it here, right? Now if you see, with this placing here, I can place this instead of here, I can place it here, right? So let me take it. This is nothing but a stars and bars concept. Wait a second, where it is. Okay, right. Now if you see, I was placing the another corridor here, and wait. Okay, so let me take it right here. Now, now I was placing the corridor here and the another one here. Instead, I can place it here also, right? By placing it only here, I have two possibilities, right? Now, either here or here. Now, the same thing here also, I have one possibility. Now, instead of placing it here, I can place it here, right? Instead, here I was placing the corridor here. I can place this one here, right? I was placing the first bar. That's what it is. Bar here. I can place the another bar here, right? So there are four things, right? Here or here, two, three, and four. Four into two times, right? That's what it is. That's what I want to tell you. Now imagine, just imagine, I have like this two and then four, five and then six. Now if you see, I can place only in this way. Now what I want to tell you is, here if I give the indices 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. Now the seat is here and then here, right? The first seat, the second seat and the third seat. The number of plants between the third seat and the second seat is the number of ways we multiply. I'll tell you why. 1, 2, 3. But I was having 4, right? Nothing but 7 minus 3, 4. But number of seeds I can get is 1 into 4 is equal to 4. Now, I'll tell you why I am doing this. Now, this is the second one. This is the second one. Let me change the color. This is the second one, and this is the third one. Now, this seed is the fourth one and this seed is the fifth one. Now the difference between these two is 2. How do I get the answer? Into 2. What is into 2? Nothing but 4 into 2 will give us 8. Which is nothing but I'll just have the previous where I have the multiple of 2. Nothing but 2 seats or 4 seats or 5 seats and all. And if you see here, sorry, 2 and then sorry, here I was having the second seat, right? And here is my third seat. Now two seats, 4 seats, and then sorry, 6 seats. If I got the seventh seat, I'll calculate how many plants are there between them. If I got the fifth seat, I will count how many plants are there between them. If I got the third seat, I'll count how many plants are there between them, and I'll just multiply. That's what I did previously. So how can I write the code here? Previous I'll initialize with -1 and the answer is equal to 1, not 0. Why? Because I was initializing it with 1. If I just multiply 0, it is nothing but a mistake. I'll tell you when the number of ways will be 0. When seeds are lesser than 2 or seeds are 0, that's how I'll get. And seeds are there but odd, then in these three cases we'll return 0 as the output. Now I have answer and also the previous and the number of seeds. For I is equal to 0, I is less than n, and I plus plus, what I'll do, I'll just, if it is seed nothing but s, I'll just increment the number of seeds. Okay, I have the number of seeds now. Now let us see. I have the number of seeds, and if the seeds is greater than 2 and seeds mod 2 is equal to 1, nothing but I'm going with the odd one here. When I got 7, when I got 5, or when I got 3, I'm talking about that. If I got like this, I need to place where is this previous. Previous is where I got it as a seed. So if it is seeds, right? If this is a seed, then what I'll do, I'll just change previous is equal to I, right? Now, if seeds is greater than 2 and seeds mod 2 is equal to 1, then I'll just make answer is equal to answer into I minus previous. That's it. I'll be using the modular arithmetic. Now, previous will become I. Nothing but whenever I got a seed, now plant, and then a seed. Here I got a seed. I think let us take it like this. Wait a second. Okay, seed and then a seed. This is the second seed and this is the third seed. Now here is my previous. Now the I goes here, right? This is the third seed. Now if I give the answer 0, 1, 2, 3, 4 and then 5, 5 minus 1 is 4, right? I'll be having 4 bars. That's what it is. I'll be just multiplying and then at the last we'll just return the answer. But we need to check these three conditions, and I have given the code link in the description. Go and check it. And thanks for watching this video. Please do like, share and subscribe to my channel.